A Chinese lab trained a frontier AI model for $5 million. American labs spent hundreds of millions on models it barely beats. Here's the trick. Start with the receipts. DeepSeek V3, the model V4 is built on, cost $5.6 million to train. That number comes from DeepSeek's own paper on ArgZiv. GPT-4, around $78 million per Epic AI. Gemini Ultra, roughly $191 million per the Stanford AI Index. Anthropic's CEO says frontier models in training today cost close to $1 billion. Same league, 14 times the price tag. So where does all that money go? At a big US lab, the training run itself is just one slice. Nearly half the Gemini Ultra budget went to salaries, hundreds of researchers, per the Stanford AI Index. Then there's R&D, failed experiments, ablations, data cleaning, inference clusters, chip depreciation. The GPUs lighting up for the final run are the tip of the iceberg. That's the honest version of it cost $200 million. Now DeepSeek's side, 2.8 million H800 GPU hours, and about 2,000 GPUs for 2 months. At $2 an hour of rental, that's $5.6 million. Compare that to Meta's Llama 3, which used 11 times more compute, per Nathan Lambert at Interconnects. Same tier of model, a sliver of the compute. The architecture is doing the heavy lifting. Let's look at how. Meet trick number 1. Mixture of experts. A normal AI model is like a generalist doctor. Every patient, every question, the same brain lights up. Mixture of experts is a hospital. 256 specialists plus 1 generalist, and a triage nurse at the door. She reads your symptoms and routes you to the right 8 doctors. Same building, same staff, but only a tiny fraction works on any one patient. Here's what that looks like in numbers. DeepSeek V4, which the company has previewed for this month, is reported at about 1 trillion total parameters, but only 37 billion fire per token. That's under 4% of the model active at any moment. Training a trillion-parameter model normally costs a fortune. DeepSeek only pays the bill for the part that's actually working. Trick number 2. 2 tricks, really. Normal training predicts the next word. DeepSeek predicts the next word and the word after that. They call it multi-token prediction. Trick 2B. Most labs train in 16-bit precision. DeepSeek trained in 8-bit, FP8, half the memory, double the throughput. Their paper shows loss error stayed under 0.25% versus full precision. Trick number 3 is the strangest one. DeepSeek couldn't buy NVIDIA's top chip, the H100. US export controls forced them onto the H800. Same compute, but with the communication pipe between chips cut in half. 400 gigabytes per second versus 900, so they rewrote the plumbing. Compressed the memory. Overlapped computation with communication. The restriction forced an efficiency gain the US labs never had to attempt. So how good is it? Pre-release benchmarks for V4, and these are leaked numbers, not verified, put it around 89% on MMLU, about 90% on human evil. GPT 5.4 sits near 92, Claude Opus around 91. So V4 isn't winning the leaderboard. It's within a point or two, at roughly 1/50th the API price of Claude. Now the asterisks. The $5.6 million number covers the final training run. That's it. DeepSeek's own paper says the cost excludes prior research and ablation experiments. Semi-analysis estimates the company's total GPU fleet at around $1.6 billion. As Ben Thompson put it, quote, "You can't replicate DeepSeek the company for $5.6 million. So what does this actually mean? 1. The moat is shrinking. If a lean team can land within 2 points of GPT-5 at 1/50th the price, frontier AI is no longer a walled garden. 2. Constraint breeds invention. The chip the US banned is the chip that forced the efficiency gains. 3. Open weights change the game. DeepSeek is giving this away. The compute curve isn't destiny. Architecture still matters. If you want the architectural breakdowns the news channels skip, subscribe. Next episode, we open up mixture of experts routing and ask, can you train one of these at home? See you there.